The next aspect of our data that we're going to focus on is going to be our schools information. And one thing that you might want to do real quickly that I forgot to do that, I kind of meant to do on each of these tabs, just to sort of keep all of our different groups of data visuals organized, is let's go ahead and give page 2 a more data and visual specific title, maybe something like location if you want to. And then for page 3, we'll call this schools. Now, don't get too hung up on like, this is location data, this is insights data. This is such a geolocational data heavy data set by its very nature that we're going to be dabbling in some of this location stuff, on almost every single page. And as a matter of fact, I'm going to be building a map visual on my schools page as well, but I'm going to keep its focus a little bit different from what we built here. So for our schools information, let's just go ahead and jump over here to our schools data set so that I can sort of zoom in a little bit better. Some of the information that is in the schools fields of our data set are, conceivably going to be really helpful for helping someone who might be considering purchasing a property in the Austin, Texas area, identify maybe where they want to live, where they want to buy a property for a business, maybe where they want to purchase some land. And for those people that have families, things like how many primary schools or elementary schools or middle schools or high schools are nearby may be important for consideration based on whether or not they have a family or are starting a family or already have maybe multiple kids at different ages. And, obviously, knowing how far those schools are is important to families. Knowing, the average rating of schools. Am I purchasing a house that's in an area or district that has really good schools or underperforming schools? Those are important considerations, maybe based on the family's means to choose different areas of Austin, Texas, or, maybe they, have different budgets that give them the options to live in areas that may have better schools as opposed to poorer schools. Things like the average number of students or how many students each teacher has that they're responsible for serving. All of those are important considerations for anybody who is picking a potential home or residence with the education of their children and their families in mind, right? If you're wondering about the median students per teacher, I can tell you that when I have classes with fewer students versus more students, I'm able to give each of my students more individual time because I have more bandwidth to sort of spread around. When I was teaching in South Korea over a decade ago, I had, I think 7 to 9 classes, each with 30 students. And I saw each of those classes for maybe 40 minutes a day. So, when you really start to, divide my time by the number of students, you realize that at most, a lot of my students were maybe getting 90 seconds to 2 minutes of my focused attention on average, of course. And so these are important considerations that families are making. And this is important information to try to visualize in our Power BI report for somebody to slice and dice and try to understand, where are different pockets of schools, in our data set that might make more sense for someone who's like looking at a property. So the first thing that we're going to do is I'm going to pop over to my summary insights page, and I'm just going to go ahead and copy my brand new card visual because I'm going to be using this as kind of a baseline. And I want to make sure that I have a card visual that's already kind of pre-configured with some of my formatting selections. And I'm just going to drop some of my school measures into this. So, the first thing that I want is the average, actually school distance. I'm just going to leave that out for now. Let's get average school rating. You can see that by default, Power BI is just counting my school rating, which there's not a whole lot that I can do with that. So let's go ahead and select average school rating. I want average student size. I want definitely the median number of students per teacher, and I'm just going to average that. Let's take the average number of elementary schools And I should have put average number of primary schools before that. Then we'll take the average number of middle schools and the average number of high schools. And you'll see over here, all of my cards are getting super, super boxed in together. It's almost impossible to read any of this. No problem. This is super easy to fix in the new card visual. What I want to do is I want to take my layout, and instead of choosing a horizontal layout, let's make this a vertical layout, and it's instantly much, much easier to read. Now let's go ahead and let's see. Let's go to our cards. And I do want narrow as my formatting. I just wanted to make sure that that was turned on. Let's go to my callout values. I think that 30 will work. And I'm going to choose none. That looks good. Decimal places, maybe 1 for all of these. Spacing, I definitely want to keep everything pretty tightly spaced. I think 5 will probably work. And for my labels, let's just leave those turned on as is. Now, one thing I'm noticing is that my average school size, I'm missing a comma. Let's see if we can get that forced in by just going here, since this is a numeric value. Yep, I was able to turn my commas on without creating a DAX measure, just by clicking on it and selecting my comma. Now let's quickly go through and give all of these I should say shorter, more easily readable titles than what Power BI generated automatically. I'll call this first one average school rating. Hopefully I have enough room without that getting cut off, and I did. Average school size. Median students per teacher. This is probably going to get cut off here. Yep, not even close. Let's go ahead and do average primary schools, average elementary schools, average middle schools, and average high schools. Okay, so we've got sort of a summary of our school data here. Now let's go ahead and add a map back onto this thing. So I'm going to go ahead and grab my, again, just very generically named map visual. I'm going to put it roughly here, like so. And let's go ahead and, of course, go to our location data. Again, the whole reason that I put all of my location information into one place was so that I can easily find it in my location table. Let's just go ahead and grab longitude and latitude. Let's make sure that those are not summarized. That's looking pretty good. I'm not going to put anything in my bubble size here for now. I might change my mind later. But what we're going to do is we're going to create a couple of different groups within our schools table that are going to allow someone who is looking at this big, messy map of dots to more easily navigate things like where the highest performing schools are, where the smallest and largest schools by student size are located, and also where the lowest and highest median students per teacher are located. So let's go ahead and head over here and create our first group here. And, you could do this, something like this in the Power Query editor. It'd be totally easy. For something, super simple and kind of one-off like this, I also sometimes prefer to just do it here within the report builder. All you have to do is, first, let me demonstrate why we're going to be grouping these things. So I'm going to go ahead and drop my average school rating into my legend. And you can see it's pretty busy, pretty colorful. I've got a lot of yellows here, which it looks like go with, 7 is kind of what this mustardy yellow is. But you can see I've got a ton of values in my legend here. And I've even got things like 6.7, 6.5, I guess it's a little bit easier to see that, wow, there's a lot of schools with a 7 ranking kind of here in the middle. But I think it could be even easier to navigate all of this information if we sort of grouped these numbers together. So let's go ahead and just back out of that. And what I'm going to do here is I am going to just sort of group all of these ratings by, let's try something like poor, average, good, exceptional. I mean, personally, I'm speculating a little bit as to what makes truly makes one of these ratings good, bad, or exceptional. It's probably not on me to evaluate the schools around Austin, Texas, based on these scores. I don't know anything about it. So, but anyway, let's just go ahead and say, assuming that these scores are oriented in a way that 0 indicates a lower school score and 10 indicates the highest possible school score. Again, you can change up these groupings as you want. I'm doing this for sort of demonstration purposes. Let's say that anything rated lower than a 5 is a poor school rating. Then I'm going to take anything that is, let's say maybe 5 to 7, and we'll call that average. And then we're going to take anything that is, ranked in the rated in the 7s and 8s, and we'll call that good. And if you got a 9, or it doesn't look like there are any 10s in here, but 10 would also be included. If you got a 9 or higher, we're going to call that an exceptional school. And so I'm just going to call this, we'll call this rating group. Or if you want to, keep all of your groups together, you can call this group. Then we'll put rating in parentheses, since we're going to be creating multiple groups. And now we can just quickly demonstrate here why we did this. Now notice, okay, at least at a glance, the way that I chose to group these, it looks like, sort of the south and eastern part of Austin, based on this data set, may have some of your lower rated or lower performing schools in the vicinity of houses that are located in this geography. Whereas it looks like, maybe to the west of, the Austin sort of, I would say, urban area, you have some, the exceptionally rated schools and good performing schools. And then you have a lot of the, sort of average performing schools sort of running down the middle. So it at least, makes it a little bit easier to unpack that rating information by just sort of binning all of those various ratings into just 4 groups here. The next bin that we're going to create is going to be around school size. So let's go ahead and just click our school size. We're going to right click, go to new group here. I'm not going to use bins. I'm just going to use lists. And let's just go ahead and say that any school that has 400 to 600 students, we're going to call that very small. We'll call 700 to 900 students just regular small. Next, we're going to say if you have 1,000 to 1,200 students, your average, or let's call this medium. I'm not sure what average means in that context. And then let's say if you have 1,300 to 1,500, you're a large school. Anything over 1,600, you're a very large school. So just 5 groups there. Then we're just going to swap this out to see how this looks. Looks like our very small schools are located sort of east of the downtown Austin area. There's a lot of medium schools, a lot of small schools that I see. Very small schools are there, and our larger schools are kind of scattered. But it looks like there are some pockets of very large schools too. One here, kind of here. With, like I said, a lot of large and small schools kind of running all over the place, and a big cluster of medium schools kind of there in the middle. And last but not least, let's go ahead and group our median students per teacher categories. And I think I'm going to keep this one pretty small. First, let me go up here and change the name of this to group size. And the next one is going to be a new group. We're going to create another bin here. And we're going to say, going to call this group any teacher that has, on average or median, I guess, 10 to 13 students. We'll call these small class sizes. And 14 to 16 students can be medium class sizes. and everything else can be large class sizes. And we'll call this group SPT, or students per teacher. We'll see how this looks in the legend. And it looks like by and large I'm seeing a lot of medium class sizes. If you recall, we had a lot of pockets of smaller schools kind of east of Austin. Makes sense then, I guess, that we have a lot of smaller class sizes. And then a lot of our large class sizes looks like are kind of north and east, or north and west, and maybe southwest of Austin. So the next thing that we're going to do is, now that we have these groups, we're going to create another parameter to allow users to reconfigure this map on the fly using these groups that we created here. So let's go back up here to our modeling, and we're going to create a new field parameter. I'm going to open up my schools, and we're going to use our different groups that we created here, and we'll call this parameter school groups. I'll go ahead and add a slicer to the page as well. Then we're going to go ahead and swap out our legend in the map. We're going to get rid of group SPT. I'm going to go ahead and grab my parameter for my schools and drop that in. And now you'll notice that we're able to dynamically change the legend of this map based on our selection over here. And while I'm here, let me just go ahead and I think I'm going to use the new slicer here. Let's go ahead and change its layout. Oh, there we go. I thought I missed it. I got the new card slicer instead. I'm going to have to sort of reorient all of this later, but for now, let's see. Let me go ahead and drop that background out of the way. Rectangles are fine for my layout. One row is all I need. Don't need a whole lot of space between the buttons. And now my users can just use this up here to change everything. Now you'll notice that right now I still have the names of the different groups here. That's probably not the best way to represent these options. So what I'm going to do here is I'm just going to click on my parameter for the school, and you'll see the code up here appear that is driving those parameter buttons. And so let's just go ahead and change. You'll notice that this first item here, these are in quotation marks. These are just the names that are being created here. I can call these literally anything that I want to. If I want to call this first one Bill, it doesn't matter. Let's just go ahead and see, now I've got Bill here. It doesn't make any sense. So let's just call this school rating. We're going to call the next one school size. And lastly, students per teacher. And you can see that now those are appearing here, so that if I want to know how school size is distributed across Austin, students per teacher, there we go, based on the locations of all of these properties. The next thing that I'm going to do, just to sort of round this out, is I want to utilize this area over here. And so one thing that I thought about when I was designing this is maybe it would be useful to someone to be able to slice and dice this information by zip code. To just let people come in here and say, oh, I want to look, I want to consume this data like this. Okay, here's a large zip code. Well, that's one way that you could do it. However, because Power BI visuals are interactive and they can, sort of filter each other, and that's the whole reason that we changed our settings early on in this lesson from cross-highlighting to cross-filtering, is because we want to use these visuals together. So I'm going to drop another stacked 100% bar chart here. I'm going to grab my zip code and use that in my y-axis. And I'm just going to use the measure that I created up here. I'm going to use my property counts in my x-axis. Let's go ahead and change. Right now, the y-axis is looking kind of wonky because it's recognizing these zip codes as numbers, not zip codes. So let's make this a categorical y-axis instead of a continuous y-axis. And now I get something like this. Because I have this thing sorted by property count, even though these are all stacked to 100%, my larger or my zip codes with the most properties are here at the top. You'll notice as I move down my cursor that the number of properties is declining. But now let's go ahead and let's add a legend here that uses the same school group parameter that we just created, so that now we can sort of compare by zip code the same information that's happening over here. I'm trying to make room for my legend values, but it's not terribly important because we already have a legend here. So having this legend is a little bit redundant anyway. So I don't think I'm going to be able to fit it all in there. So let's just get rid of it entirely. But now, the whole point is, let's say that I'm over here looking at my school rating information, and I want to find some areas where the schools are truly exceptional. You know, like right here, I've got this 78739, and it looks like, 43% of the schools are rated exceptional. Okay, maybe I want to see, what that zip code looks like zoomed in. And you can see here, okay, it looks like there's a nice grouping of houses here that are located near an exceptional or multiple exceptional schools. Mentally, I have kind of a block where I'm thinking all of these are schools because I keep talking about schools. It is important to remember that these are not the schools themselves. These are the properties in our data set that are located near these schools. So it looks like, there must be a really fantastic school, or maybe it's this James Bowie High School. I mean, that could be pretty cool. We're actually able to find the specific school. Whereas it looks like this Gordon Bailey Middle School is a good school. Maybe if we keep zooming in over here, we'll find another school. But yeah, I mean, like you can almost sort of extrapolate from the data and the map what those exceptional schools are. Let's go ahead and head down here, and looks like here in this zip code, there's another very exceptional school. Might be the St. Stephen's Episcopal School. I'm going to keep zooming in. Maybe this Cedar Creek Elementary School or this middle school are the exceptional schools down here. Maybe they're all exceptional. You can see that, a huge 92% of the properties in this zip code are located in relatively close proximity to exceptional schools. So again, the whole reason that we do exercises like this is to try to make a sea of dots on a map a little bit easier to navigate and get somebody who is consuming this information starting to ask the right questions. So, again, later on in this lesson, we're going to be building a slicer panel. Maybe if you zoomed in on this area and you saw, okay, it looks like there are some really good and exceptional schools here. And maybe you're thinking, oh, it looks like maybe this middle school is exceptional. I am a parent of a middle school student, could be something that your user is thinking of. Maybe I want to try to see if there are any houses in this area that really check all the boxes that I'm looking for. So at the end of our lesson and our tutorial building this report, once we integrate our slicer panel, then somebody could take this school view and say, okay, only show me houses that are within this price range, which is my budget, or only show me houses that are, at least this large or have this many bedrooms or, meet all of these things that I need for my family. And if one of those, let's say maybe this random property checks all of those boxes, then you can see that it looks like it's within walking distance of an exceptional middle school. So that's the whole reason that we're sort of doing this exercise, to try to get more out of the school's information in this data set. The last view that we're going to build for our Austin Housing Data Insights tool is going to be heavily oriented around a lot of the remaining features and attributes in our data that we haven't used yet. I'm going to be spending some more time visualizing things like houses that have homeowners associations, cooling, heating, garages, spas, views. I'm going to be working with this house table that we created that has different aspects of some of these properties in the data set. Things like the number of accessibility features, how many appliances are in the property, how many bathrooms, how many bedrooms, how many parking spots, how many stories, things like that. And ultimately trying to sort of boil all of this information down so that we know as someone who may be using this tool or trying to understand all of these many fields about this data set. What does this ultimately mean? Yes, we have all of these different attributes of our houses, and we could easily build a bunch of bar charts showing how many houses have one appliance, how many houses have two appliances, how many houses have 3 bedrooms or 4 bedrooms. But that's a lot of information to digest. Ultimately, we want to try to use this page to get to the bottom of what does it mean? What, about these different properties might people with different budgets find appealing? How might people who are consuming this information use the insights that we're giving them to sort of evaluate their options and ultimately sort of find out what do all of these features really mean at a very foundational level. So we're going to be building a lot of data visuals here. As I was sort of practicing building some visuals to teach you on this lesson, I also ended up running into a fair number of performance issues. Honestly, some that I found kind of frustrating because I've got a pretty powerful PC. I very, very rarely run into any sort of lag or visuals not loading because of the size of the data set. And I mean, at the end of the day, this is not a huge data set. My description table does have, about 740,000 rows, something of that nature. This is a fairly big table for Power BI to churn through, but still, I wasn't expecting some of the performance issues that I ran into. And it took me some finagling to sort of figure out, what might be a solution. So you're also in this lesson going to get some performance tips to help you sort of work around some very common loading issues that you might have with more complex data visuals and DAX techniques. And so this is not something that I teach a whole lot, because running into good performance scenarios, those can be kind of hard to create or to fabricate for demonstration purposes. So I was actually kind of excited when I ran into a pretty good, easy to fix example of a performance issue, and I'll kind of walk you through what the problem is, why Power BI is manifesting the specific problem that I'm expecting to run into, and how we're going to work around that problem, and why the solution that I'm going to teach you, why it actually works. But to start things off, we are going to kick off this lesson with a couple of fairly simple data visuals and some fairly simple techniques before we get into some of the more complex issues that are going to come later in the lesson. So just as a warm-up, let's go ahead and build out just a simple bar chart here. We are going to use a clustered column chart. And I'm going to try to glean a little bit more information from our features pivot here. And I'm going to use my median home price DAX measure here. And I'm going to drop that into my y-axis. You can see I've got median home prices of $405,000. And the question that I'm trying to answer is whether or not the features in my pivot table here, and if you'll remember, those features include things like whether or not the house has a homeowners association, whether or not it has cooling, whether or not it has a garage, whether or not it has heating, a spa, a view. And we want to know whether or not having these things influences housing prices to be higher or lower. And so we're going to just go ahead and grab our attribute here, and we're going to drop this onto our x-axis. Immediately you can see all of my values here are the same. That's totally fine. That's just a byproduct of the way that we set up our data model here. So the only thing that we need to do to round out this visual is let's go ahead and grab our value here, which, if you'll remember, contains yes and no for every single property as to whether or not it has that specific item. And let's go ahead and drop that into our values for our legends. And the first thing that we can highlight here visually is that it looks like if a house has a spa, that contributes to a pretty big increase in median home prices, as well as if it has heating, if it has a nice view. But you can see that across the board, it looks like having versus not having all of these attributes pretty well aligns to home prices being higher than they might be otherwise. And so let's go ahead and go to our properties here real fast. Let's drop down our advanced options. Let's turn off our attributes. And one thing that I'm going to do On my x-axis, attribute is just what Power BI chose to call this column. When we were modeling it, when we were pivoting this table, attribute is not likely to be an x-axis title that would be really significant or meaningful to our users. So we're just going to turn off that title instead of giving it a different one. You can play with some of your spacing a little bit if you want to here, but I'm just going to kind of leave it as is. Then the next thing that we're going to do is let's go ahead and give this, again, we're going to come back later in the next few lessons and come back and update our formatting and everything and make this report look gorgeous. But for now, we're just trying to kind of get most of our core ideas onto the page. So let's give this a title of, does median listing price or home price, whatever you want to call it, change with let's see, change based on different features being available. Feel free to wordsmith this title. In the interest of time, I'm trying to move through this section pretty quickly because we have a lot of ground to cover in this lesson. But you're really just trying to make sure that the user is clear on what is being demonstrated here. That they're supposed to be comparing whether or not the median listing price is different based on whether or not these different features exist. The next visual that we're going to create, we're going to utilize the built-in field parameters feature of Power BI, which I find really, really cool. When, let's say, you have a table like this house table that contains a bunch of different features, more features than you possibly have room to visualize succinctly on one Power BI report page. And maybe you don't know, right out of the gate, which of these to focus on. So what we're going to do is we're going to quickly go up to our modeling options and we're going to create a new field parameter here. And I'm going to grab almost everything from this table. And I'm even going to grab a few things from, let's see. I think I might even try to grab some things from my housing fact table. Let's grab year built. And let's do lot size and living area. And while I'm here, let's see if Power BI will cooperate with me if I change this to garage spaces. See, so I will say that sometimes there is a bug in Power BI that manifests. It might just be with the version that I have. At one point in time, and maybe on your version, you can go in here and you can just, double click on any of these and give these columns that you're adding from your data set and the field parameter new names. But I've noticed that at least in the version that I have right now, that does sometimes cause Power BI to glitch. So it's not a big deal. This is, again, totally easy to work around. What I'm going to do really quickly here is I'm just going to, if you didn't notice, my garage spaces, as I gave it a new title, it just vanished entirely. So it's fine. What we're going to do is we're going to give these new names in a different way that's also not very difficult. Let's go ahead and just create our field parameter first. Over here is our slicer. Let's go ahead and just click on our new parameter table over here. And I'm just going to go here to my names for each column. And again, these names that are generated, this red text, this is what is generating the names in my slicer here. So we're just going to change this to, and just to be consistent, number garage spaces, let's see, number accessibility features, number appliances, number bathrooms, number bedrooms, number of community features, number of parking features, number porch and patio features. And again, I'm not quite sure what a parking feature is, but it does sound fancy. Number of stories. If you even want to put levels for added clarification, you can call these whatever you want to. Number of waterfront features. I inadvertently added of up here, but I want to be consistent, so I'm going to delete that. Number window features, number parking spaces, year constructed, lot size, square feet, and living area, square feet. And as soon as I hit enter here, you'll notice that all of my slicer values down here have changed. What I'm going to do is, because there's a lot of items here and I don't necessarily have room for all of them, I'm going to change this from a vertical list to a drop-down slicer. And I'm just going to kind of move this right here. I've got something else in mind for it a little bit later. And I'm going to go ahead and add it doesn't really matter which of these two you choose, but I just need a bar chart with a line. Actually, now that I think about it, I think that almost anything will work. So all I need is just a bar chart. Clustered bar chart should still work because I'm going to be using the trend line that is one of the analytics tools built into this specific visual. And the next thing that I'm going to do is I'm going to grab my parameter that I just created, and I'm going to add that to my y-axis here. I'm going to make sure that something is selected. Let's start with the number of garage spaces. Then I'm going to grab my median home price. I'm going to add that to my, I just realized my parameter should be on my x-axis. And there we go. And now that I have that, let's go ahead and add a trend line here. And what this visual is going to allow us to do, and let's go ahead and click on that. One thing that I want to do is I want to go up here to Format. I'm going to send this visual to the back so that I can still see my slicer here. But what this visual is going to allow us to do is basically visualize whether or not, having more garage spaces is correlated with higher, actually, I meant to grab median house prices, is correlated with higher median house prices. And you can see it looks like there is a slight trend, which I think is intuitive to anybody. I mean, what do you typically associate with more expensive houses, at least in the United States or at least in Kentucky? For my part, if I see a house with, a 10-car garage, I think I probably can't afford that house. So it doesn't really surprise me that we would see, a positive trend line when we visualize median home prices against garage spaces. We can even test this with a few other things. Does the number of bathrooms tend to be associated with higher priced houses? And it looks like we've got a pretty big outlier here. This is probably the $13.5 million home, and it is. Looks like that house has 13 bathrooms. Number of bedrooms, surprisingly, we see a slight downward trend. I don't know if I buy it. There must be something going on in the data, but that could be worth exploring. And let's see, number of stories and levels. Yeah, huge, definitely seeing something there. I don't know how many houses or properties in the data set have 4 stories or levels, but it must be a gigantic property. And of course, it looks like it's very expensive. And we can also even glean some other insights, such as it looks like as lot size increases, and we've got a gigantic lot way out here, a huge outlier. One thing that I'm going to try to demonstrate, if I can hover over it, is we can also exclude that data point if we want to get rid of that specific outlier. And if we want to continue grabbing some of these outliers that exist here, some of them are really hard to sort of hover on at this view, but we can just keep excluding some of these that are way out here away from the rest of our data. We'll exclude that one too. And now we're starting to see that, positive correlation that we would expect, where we're seeing, as lot sizes increase, we're seeing, that median home prices are increasing. We can probably even test out, the exact same thing for living area. Obviously, if you're getting more house or a larger property, those tend to be more expensive. So just kind of giving you a crash course in how this works and why we set up this visual this way, and also the flexibility that you can offer your users of your report using something like field parameters in your report. It's a really, really useful interactive feature that's not that bad to set up, but for me, allows you to conserve a lot more space on your report, especially when you have a dimension in your data set, like all of these different numerical fields, where you would essentially just be creating the exact same visual over and over and over again. Instead, you can just build a field parameter and give the user the ability to sort of select which item from the data they want to evaluate. The next part of the lesson is where I started to run into some performance issues when I was, putting together ideas for this tutorial. And honestly, like I said, I'm kind of excited about those performance issues, because it's going to allow me to sort of highlight for you why this particular error is happening and some techniques that you can use to get around it. And again, I'm excited to sort of explain to you why, within the context of a Power BI report and sort of how Power BI processes data, I was able to get this solution to work. So what I wanted to do here was, the whole thing that was a catalyst for this is I wanted to set up some sort of visual that would allow us to use the data in the description table that we set up, that contains all of our properties and the many different words that were used to describe these properties, and try to figure out, what words do the people that, put together these descriptions of properties, what words do they use more commonly to describe the houses that are listed for less than, let's say, $250,000 versus houses that are listed at $1 million or $2 million or $10 million. Are they all just saying, hey, this house has a nice kitchen, or this house has a couple of bedrooms? Something tells me that they're probably not. They might be pitching or highlighting different features of less expensive houses and other expenses for the types of houses that, your Bill Gates or Jeff Bezos probably lives in. It stands to reason, right? So in order to do that, we end up with a pretty complex visual situation. In fact, the more that I thought about it, we end up with a situation where what we really need to do is sort of rank all of these words to find out, in different situations, what are the most common words being used. Because yes, we could easily just, here, let me go ahead and add a count of my description table. We could easily create a visual where we're just ranking by the number of times that the word is used. We've got things like home, kitchen, room, Austin, large, new, contains. Honestly, there are a few words in here that I'm probably going to take out before we do this exercise, because again, of course the word home appears a bunch of times. And of course the word house appears a bunch of times. And contains is a word that doesn't really tell us anything. So we're going to do a little bit of cleanup here. I'll probably get rid of the word Austin, since all these houses are in Austin, Texas. But, what do we do when we need different words to appear based on the listing price of the house? This is going to require some dynamic ranking. So one of the first things that I did here, and hopefully this error will happen again since it happened when I was practicing, we could easily set up a, let's call this word rank. First, actually, I'm going to do a word count measure. And this is going to be exactly like the count of ZPID that we just did down here. I'm going to go ahead and get rid of the other one. We're just going to use our word count measure here. I want to make sure that it's formatted correctly. And the next one that we're going to do is we're going to create a word rank formula. And this is going to rank everything in the values column of our description table. And so I'm using all selected. And word count is the measure that we're going to use to rank these words. So what we're expecting to see is that home right now, the way that we have this configured, is number 1, kitchen's number 2, room is number 3, Austin's number 4, large is number 5, so on and so forth. And I want these ranked in descended order. So I have 1, 2, 3, 4, 5. As my word counts go down, my rankings go up. And for my tiebreaker, dense is totally fine. So we have our word count ranking here. Works just fine here. I see rank 1 when I have no other values. Doesn't really make any sense. In order for this to be useful, I need it visualized in the context of this table here. And lo and behold, this time it worked. Before, I was running into an error. I could not get this thing to load. I was setting everything up exactly the same way. And I was wondering what the heck is going on here, because even though 738,685 rows might seem like a lot, it's not. This is nothing that Power BI can't handle. So whatever was going on with my computer looks like it's worked itself out. Not a big deal. I still want to show you some other techniques for resolving this same issue, because we can absolutely make this report run even faster, and we can make this visual have even less restrictions on it. So what I'm going to do here first is I just want to point out to you where there are efficiencies to be gained in this table. And so, of course, if we look over here, we have 738,000 rows, almost 740,000 rows. The word home repeats over and over. The word Z-estimate repeats over and over. So, one thing that we could have done is, we could also just start right here and create a table using DAX. And for this table, I'm going to call this word summary. And I'm just going to say, hey, Power BI, I want you to return only the distinct words from my description table. And the table that this DAX creates is just a list of my distinct values. I'm going to go over here, find my word summary. Here's everything. You can see it. Let's go ahead and sort this in, order so that you can see there's no longer any sort of repetition in my words. And then what I had done before in my practice was I went to my relationship here, grabbed my word summary that I created in DAX, and drag this over here to my description table, and I just created a relationship this way between my summary table and my original table that contains my 700,000 rows or whatever of words and all of my IDs that sort of map everything together. And then I told Power BI, hey, instead of using the values that repeat over and over again in my description table, I'm going to swap that out with my summarized word table. And you can see now, notice it is slowing down. There's something going on here. This is easy to fix. Notice that I took description value out of this table, and I'm now asking it to rank those values. Rank is not going to perform well if I'm using the wrong item from my data model. That's why it's saying the visual has now exceeded the available resources. So it's looking for word summary value, even though I'm telling Power BI in my DAX that what I want to rank is description value, not word summary value. Notice that if I just change this out with word summary value, loads super, super quickly. There's my values. Now everything's working again. I've got all of my rankings exactly the way that I wanted them. In the version of Power BI that I was working on in practice, this also threw an error. And the reason that it threw an error was that my word summary table was being created using DAX. In other words, every time I did anything, Power BI was having to sort of reload or recalculate this word summary table, which doesn't take a lot of energy. This is just, sort of consolidating the unique values from my description word table, but I was still running into performance issues. So the way that I managed to get around that was to basically do what I just did here using DAX, where I summarized all of my words, and I created a different summary table using my description table. And instead of setting it up the way that I did in DAX, I basically did the same thing, but I created a reference table, and we'll call this one Word Summary Power Query Editor, just to keep it separate from the one that we created in DAX. And let's go ahead and just quickly remove our ZPID, and we're going to make sure that we remove all duplicates from this table. So we are effectively, creating the exact same thing. I also want to make sure that I'm removing any blank rows that might exist in this table. If I have a value that is just blank or empty, could run into some issues later on. Now let's go ahead and head back over here. We're going to let our new word summary PQE table load in. Should be about 10 to 11 megabytes. Doesn't take very long to load it in. And once this is done, notice that our new word summary PQE table is over here by itself. I'm going to go ahead and pull this over here. I'm going to go ahead and delete my DAX table relationship. And in fact, I'm just going to go ahead and delete my DAX table entirely from my data model. And instead of using that, I'm going to plug up the new word summary table that I created in the Power Query editor. Let's go ahead and attach that. It's saying that we have a many-to-many issue. It's not material though. I'm just going to go ahead and try to use this. And notice next that the word summary PQE table that I created is only 29,276 rows. So it's so much smaller than the values over here in my original description table that has 738,685 rows. So what we're going to do now is we're just going to quickly drop the value from our DAX table that we just created and deleted. We're going to grab our new value from our word summary PQE table. I'm going to go back up to word rank. It is now throwing an error because I deleted the word summary table. Let's go ahead and hook back up our PQE value. And notice nothing changed, but this thing is now loading almost instantly. And if I want to click on something else from my data set, let's try this. There we go. So now I can see that, okay, houses with no garage spaces, these are some of the words that they're talking about. Everything's updating dynamically. And because I'm using all selected here in my ranking, I'm always going to see the rankings of 1, 2, 3, 4, 5. Everything is being dynamically re-ranked as I click on things and interact with my data set. But this still isn't quite good enough. This still isn't quite going as far as I wanted to go for this demonstration. So what I'm going to do real quickly is I'm going to head back over to my word summary PQE. Something else that I'm going to do that I meant to do when I was building out my original descriptions table that could help clean some of this up is let's go ahead and add an additional transformation, and we're going to trim. And trimming is going to take out any sort of oddly placed spaces or line breaks that could be throwing a little bit of additional wonkiness into this thing. And then once we have that, we're going to go ahead and just remove some additional words here and just kind of keep cleaning this up. So I think that the word the is still appearing in there. We definitely don't need that. I want to get rid of words like home and homes that we noticed that were still there. I'll get rid of house. Let's try getting rid of, if you'll remember, the word contains was popping up a lot. Let's see. I think we're good on some of these. I like to get rid of words like, awesome, terrific. You don't have to spend too much time on this. Again, spend about as much time as you feel comfortable with. But we're trying to get, as many just kind of junk words out of this as possible. I mean, I guess maybe it's helpful to know that, at this price point, maybe, the listing agents like to use words like great. And at this price point, they like to use words like awesome. I find that all a little bit tedious and meaningless, but maybe that's just me. But anyway, clean out the junk words, as much as you feel comfortable with. And then we'll load some of this stuff back in. And we should almost immediately notice the changings to our rankings. Just thought of one more word that I wanted to take out. There we go. I'm going to also take out the word Austin. And let's also take out the word Z-estimate, since that's also something that appears almost everywhere in the data set. And then once this loads, we'll finish setting up the matrix visual that's going to help us more easily sort of digest the changes in words that are being used across houses that are listed at different price points. So we have the main formula that we need here. The next thing that we're going to need to do is, it's not going to make any sense at all to try to digest all of these words by all of the price points that we have in our fact table. We can't create a unique ranking of words for, all, I don't know how many values are in this thing. I hesitate to even, we're going to need to figure out a way to summarize these prices, right? So what we're going to do is, I'm going to click on latest price, and we're going to do an exercise similar to what we did with our school districts. And I'm going to, whoops, clicked on the wrong thing. I'm going to right click on latest price, and I'm going to create a new group here. And again, instead of using bins they can be really useful. If we used a bin, you can see that it's going to create breaks for us at every $269,890. And this is fine, but there is a lot of skew in this data set. The skew in our data set is because, most of the houses, by and large, a lot of the properties that are in this data set are, less than $1 million. But these are properties that are, by and large, trying to accommodate, your average family. I'm sure Austin, Texas has plenty of wealthy people, but there just aren't a whole lot of, $5 million, $10 million, $15 million houses or properties in the data set. So we're going to use a list here instead, and I'm going to manually create my own price breaks starting at $250,000. So I'm just going to grab $250,000, hold down Shift, grab 5,500, and those immediately disappear. Next, I'm going to scroll all the way down to $500,000. Once I have that in sight, I'm going to go ahead and grab that, go back up here to the top, create a new group. Next, I'm going to grab 750. Then I'm going to grab 1 million. And then I'm going to start to increase my bands a little bit. Let's grab 1.5 million. And then let's grab 2 million. And then I'm just going to grab everything else. Okay, now that we have that, let's go ahead and collapse all of these bands that we created. And I'm going to call this first one less than 250K, or less than or equal to 250K. We'll call the next one 250K to 500K, or I guess technically 251K. As a matter of fact, I'm just going to call this one less than 251K. For the next one, it's going to be 501K to 750K. Then 751K to 1 million. 1 million to 1.5 million. 1.5 million to 2 million, and finally 2 million plus. Now, you might notice, even as I was renaming these things, notice that the order is getting thrown off. I've got 251K, 1.5 million to 2 million, 1 million, 251K, 2 million. So these are getting resorted in alphabetical order. That's going to be a problem for us later on, so I will come back to that. But for now, we're just going to go ahead and use these groupings. I'm going to create a matrix here. I'm going to add my new latest price groupings up here. I'm going to go ahead and grab my values down here. Actually, let me back up. The thing that I forgot to do is let's go ahead and very quickly create just a custom table here. And we're going to call this table Z word rank. And for this, we're just going to hard code in the numbers that we need. I'm going to call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're creating a dummy table here. And what this dummy table is going to do is it's going to give us a way of sort of mapping the most used words at these different price points to the values in our matrix down here. And this tends to be something pretty hard for newcomers to Power BI to grasp, because we are sort of creating the attributes that we need in our data visual to create the report that we want. And so first, I'm just going to go ahead and drop word count down in here to show you what I mean. Now, notice that my word counts are changing for every value up here in my in the grouping of prices that we created. And that's because these price groupings that we created come from our data model. I mean, latest price is here in our housing fact table, and the group is also here in our fact table. So all of that is tied together. And our word count, of course, comes from our word summary table and our descriptions down here. However, you'll notice that for every value in that rank dummy table that we created, we've got exactly the same values. And that is because that dummy table's not connected to our data model at all. So because Power BI doesn't know what to do with those numbers, it just repeats the same number over and over again. So we need to create a DAX measure that tells Power BI what to do with these numbers. And so we're going to create a new measure here, and we're going to call this measure word find. And what I want Power BI to do here is I want it to bring me the first, or you can say minimum, word that appears when the filter criteria on, and I'm going to use my PQE table again, but whenever my word rank equals the value that is being evaluated in my ranking dummy table. So in other words, I have my rank formula that I already created here that ranks all of my words, and I'm telling it whenever the ranking equals 1, then I want you to show me what that word is. Whenever the ranking equals 2, I want you to show me what that word is. So I'm mapping these rankings to the dummy values in this table that I created. And when I'm done with that, I can just drop in that measure, and it's going to show me that, okay, it looks like, here at, for our properties that are less than 250K, The top words that appear are new. People want new houses, they want kitchens, they want bedrooms, they want something that's open, they want something for their family, they want masters. And that probably holds pretty much true for properties at 500K, properties at 250 to 500K. Meanwhile, our properties that are more expensive, like 1.5 million to 2 million, they start introducing some other things like pools start to be words that are used quite a bit. Privacy tends to be things that are used quite a bit. At 2 million, we start to see things like people wanting privacy and wanting a lake and views in pools. Or at least those are the words that the listing agents that are putting together these descriptions of properties in the data set are using to describe these various properties. However, as I mentioned, all of these are still in the wrong order. So the matrix is pretty well working, but we do need to finish fixing some other things in the data set here. And the reason that I wanted to take a break is because it's going to be a little bit repetitive here. We're going to go back and we're going to do almost exactly the same exercise that we just finished. I'm going to click on my latest price. I'm going to go up here and create a new group. I'm going to create a list, and I'm going to scroll back down to 250. I'm going to grab all of these, and then I'm going to grab 500. And I'm going to group all of those. Now let's do 750. I'm going to group all of those. Then 1 million, then 1.5 million, then 2 million, and of course we're almost done here. Now I'm just going to grab everything that's left over, and I'm going to group those. Let's go back up to the very top here. Let's collapse everything because it's just going to make it a little bit easier. And I'm going to call the group that corresponds to properties less than $250,000, I'm going to call that 1. And I'm going to give all of these new numerical rankings, and these are going to be what I use to sort all of these values. So I'm just going in order by group here. And once I have this new column here, I'm going to click on my original column here. And if you want to, you can give these different names. Like let's call this latest price group. And I'm going to call the next one latest price group order. And now I'm going to click on latest price group. I'm going to go up here where it gives me different options to sort this column, and I'm going to tell it that I want it to sort by the latest price group order column that I just created. And now you'll notice that all of my columns are in the right order, going from left to right. So I have less than 250K, 250 to 500, 500 to 750, 750 to 1 million, all the way up to 2 million plus, which makes it a little bit easier to visualize changes in the top words that are being used to describe houses at these different price points. So you can really see that, okay, it looks like, around $1 million is when people start to say, hey, it'd be really nice if this house had a pool. And then pools continue to get more important, or at least more sort of central to the descriptions that are being used for these houses as the listing price increases. And then you see things like lakes and views start to appear, and privacy start to appear in some of these. So this is just one way that I thought, could be kind of cool for visualizing all of this descriptive text data that we have. The other thing that I'm going to do is, however, summaries don't really make much sense for text data, so I am going to turn those off. And now we've got our matrix. The last visual that we're going to add to this page is going to be a key influencers visual, because this is ultimately going to be the best way that we have of sort of taking the different attributes of these properties and figure out what really drives the listing price or asking price of any of these properties. So price is what we're going to be evaluating. So, and we're going to change the name of this from latest price to listing price. And we're going to ask ourselves what influences listing price to increase or decrease. That's kind of built into the key influencers visual. As soon as you give it a numeric value, it's automatically going to use the built-in algorithm of the key influencers visual to try to determine what is driving this specific numeric field in your data set in one direction or the other. And now it's saying, okay, we don't have any fields in our explain by, so it's not giving us any insights yet. We're going to need to go over here and tell this to explain the listing price by something from our data. The first thing that we might want to evaluate is whether or not listing price changes based on year built. And you can see here it says year built is more than 2017 or year built is 1957 or less. This is also something that we can probably look at over here. So year constructed. Over here we see that median home prices do appear to have some spikes. Looks like for houses between 1900 and 1920. And then you can see that house prices are starting to creep back up again after 2017. And as someone who recently purchased a house, I can tell you that that feels right to me because our most recent home purchase was quite a bit more expensive than the last two houses that we bought. So year built is more than 2017, year built is 1957 or less, tends to, it looks like, correspond with higher median home prices. Good to know. Something else that, again, I think should be pretty low-hanging fruit for the key influencers visual to come up with something would be living area and lot size. So we'll call it this first one living area square feet and lot size square feet. And of course, it immediately comes up with something that when living area increases by this square footage, that it looks like median home prices increased by about $290,000. Lot sizes, a huge increases over a certain threshold can result in $800,000 increased listing price. Although we do know that with the lot sizes in our data set, there are some pretty extreme outliers in there. The rest of the features that might be very useful to throw at this thing would be in our house table. So we can use things like, garage spaces, accessibility, appliances, bathrooms, bedrooms. I'm just literally going through here and clicking all of these values and sort of dumping them into the explain by portion of this visual. And we can see number of bathrooms is more than 4.5, much more expensive houses. Number of stories more than 2, more expensive houses. Number of bedrooms more than 4. All of these things make intuitive sense, right? Especially for those of you that have maybe purchased a home or who have looked at homes or properties, even rental properties at different price points. All of these amenities, additional rooms, they cost money. They tend to increase the prices. That's why I wanted to make sure that I used the key influencers visual in this specific report tutorial, because we can already pretty well guess what the key influencers visual is going to surface from this data. It already makes sense to us that houses with more bedrooms, more bathrooms are going to be listed for more money, or houses that have different amenities versus fewer amenities. So because of that, I knew that we could kind of game the key influencers visual. Not only is the key influencers visual going to already tell us some things that we already know, this data set is exactly the kind of fodder for the key influencers visual to sort of churn through. And I don't want to diminish the capabilities of the key influencers visual. Yes, we already knew the narrative, but it is at least sort of giving us an idea of, the extremities or, the actual extent of some of these things that we already knew. I definitely would have guessed that the number of bedrooms being more than 4 would drive up a home price, but I never could have told you by how much. So at least this thing is giving us an idea of the scale of some of these drivers on listing price. Now that we have that, let's just very, very quickly go through and clean up the titles of these fields. Number of appliances, number of bathrooms. For this one, I decided to use of. Number of bedrooms, number of community features, number of parking features, number of patio porch features, number of security features. One thing that I want to point out as I'm doing this is don't assume that just because you throw something into this, that it's going to appear in the key influencers visual. You know, things like waterfront features, security features, I don't believe that I saw all of those necessarily appearing in the key influencers visual. So it did determine, or at least was, did not find conclusive evidence of some of these items actually driving listing prices to increase. Meanwhile, if you toggle this over to what influences listing price to decrease, notice that you may see some other things, like number of patio porch features as one or fewer tends to be, at least by the algorithm's determination, associated with lower priced houses. Likewise, for houses that only have 2 or 3 bedrooms, fewer parking spots, or smaller living areas. I think it's very telling that a smaller living area is surfaced as the top driver of listing price decreasing. I think that's another sort of validation of the key influencers visual, because that already makes intuitive sense, I think, to anybody that would be evaluating this data set. But anyway, now that we have all of that done, we have a great start on almost all of the pages in our report. I did flirt with doing even a 5th or a 6th page. I am going to leave page 6 here. I think we may be revisiting that later on when I start building an example of a tooltip page. So we're going to leave that, but I definitely don't think that we needed all of the pages that we set up. But now that we're done sort of fleshing out our data visuals, and we've got all of our ideas kind of down on the page to make a really exciting report, let's go ahead and start carrying all of this over to our main report page. And let's go ahead and start focusing on the designs that we're going to build to really create an impressive overall Power BI report and experience for our potential users.